we we thought of having this lecture at the initial stage of this symposium just to share the enthusiasm that we have about tuberculosis bacteria with you. The tuberculosis bacilli is really fascinating, and you will understand within the day to day how fascinating it is. When we have a certain adversary, especially when we have a formidable adversary, however bad the consequences are, we develop a certain respect towards that adversary. And there's a saying that you have to know your enemy to win any battle. So this first presentation is to create enthusiasm amongst yourselves about the TB bacteria and about its various presentations. So you have a good baseline of knowledge. It is indeed an invincible microbes. Microbes are invincible anyway. And about 2 years or 3 years back, we knew and we saw how a simple viral virus with the RNA was able to, get us, the Homo sapiens, kneeling down, begging for life. And if we really don't have mechanisms of tackling these microbes in the proper way, we will have this problem in an ongoing way. So when we look at this history of tuberculosis, unlike COVID, unlike HIV, it has a vast history. This actually history, the confirmatory history of tuberculosis starts about 9,000 years back in the Eastern European settlements, where there have been shown to be evidence, there's both skeletal evidence as well as microbiological evidence of tuberculosis bacilli confirmed by DNA being isolated from these specimens around 7,000 years, 9,000 years back. And this specimen is from Hungary, which they have isolated a 56 people graveyard, out of which about 5 or 6 had evidence of active tuberculosis, both in the bones as well as in the genetic material of these people. So tuberculosis has affected mankind for a long time. And this is an Egyptian mummy showing the spinal destruction due to tuberculosis and the Pott's disease that we know. And in the Hammurabi writings, there says, especially in the Greek civilization, there is a mention about tuberculosis and how it affects the entire civilization. And in India, the Yurg and the Yajurveda always mention all about tuberculosis, and it is called Yakshma. And the name Shaya means that it is a wasting of the disease, and they have actually identified the relationship between Madhumeha, that is diabetes, and tuberculosis, especially the Shushruta Samhita people, the two main Ayurvedic practitioners in India have identified this connection, even though now we are trying to identify it now itself. So this has been an ancient disease. Tuberculosis has been there for millennia, at least 7 to 9 millennia. Tuberculosis has been with us. Now, the modern tuberculosis was actually discovered and described by Hippocrates, but in 1679, this is a gentleman actually who described tuberculosis as tuberculosis. He noticed these nodules or nodes, which in Latin cause tuber, in patients who are suffering with tuberculosis. And he has identified the debate that we call this association between thysis. Thysis means in Greek, in Latin, wasting off. When you look at the nomenclature of tuberculosis, it is always associated with wasting. Whatever the word comes, share, thysis, consumption, everything, because people with TB, tuberculosis, gradually waste into oblivion. So that is one way here. So here they have identified, rather than two separate diseases, lymph nodes that are associated with tuberculosis, which was called scrofula when they were eruptive, was associated with cytitis or tuberculosis. And it was actually called the king's evil. And they thought that the king of the country had the power to heal these people by a simple touch. So these kings had a certain day in their calendar where people will gather around their palaces. So these kings or the queens will touch these people with scrofula, and majority of the people thought that that will heal that. So that is the king's touch, and the scrophuladerma was told as king's evil, because we didn't have any cure. So we people were looking at various things. So if you do a randomized control study, how much people have survived, we can know. But probably some of the people who had a natural healing, probably the king got the benefit of the doubt. And in 1779, we identified, the British surgeon described the Pott's disease, which some of these people had destruction of the spine associated with the neurological associations and the damage that it caused. And he described this disease as Pott's disease. And this is a beautiful description about tuberculosis. Wonderfully minute living creatures. And this was described by Benjamin Martin, because tuberculosis was thought to be due to several things. One thing that they have thought was it was a congenital thing coming from families. Because when one person of the family got tuberculosis, unfortunately, majority of the household people will get tuberculosis, and they died of tuberculosis. So they thought that it was a familial disease. And some people said that it is probably associated with the dust that is there in the curtains and in the carpets. And some people thought that this is a disease of poverty. It's again the king's evil, a god's evil. But Benjamin Martin was the first one to suggest that probably tuberculosis was a communicable disease. And this is a landmark explanation, because unless you know the causative agent of this disease, preventive measures cannot be taken, or the preventive measures that we take are futile. And again, in the 1865, not only humans are affected, they showed that animals are affected as well. So this had certain consequences, because humans consumed a lot of milk. And when humans can give the disease to the cattle, and the cattle can give the disease to the humans, there will be a significant public health concern. And this is the first suggestion that probably this is carried to the animals, as well as from animals we can get the disease. And later it was proven. And that is when the pasteurizing of milk came into the scenario in the 1900s. Right. And this gentleman, I think he's the father of bacteriology, he's father of microbiology, and his workings are spoken as a Bible of microbiology, right? Robert Koch. Robert Koch was actually an astute clinician. He's a very, he's a person who observed thoroughly of what is going around, and he was presented with a microscope by no other than by his wife after the marriage. So the says a saying that behind every man there is a woman. So this is definitely a very good example for that. So this microscope was actually presented, not this, but the primitive microscope was discovered, presented by the wife. And he had actually identified the anthrax bacilli. He drew the anthrax bacilli, and he published about the anthrax bacilli, the spores and everything, in a beautiful way, describing that. He actually developed the oil immersion lens system, right? And the fixing of these microbes. And most of these methods of staining and fixing were developed by him, thanks to him. And this is one of the first descriptions or depictions of the AFB bacilli, Mycobacterium tuberculosis bacteria in a granuloma, which has drawn in the first publication that he has done in 1882. And he developed the solid cultures rather than the liquid cultures after many experiments. And he's one of the pioneers of developing the Petri dish and the agar solution for microbiological studies. And there is no wonder that he's the father of microbiology. And this is the landmark study that he published. He presented in 1882 at the Physiologic Society of Germany, not the Pathology Society of Germany, right? There is a reason for that, because the Pathology Society didn't allow him to present it. So these problems that occurs now was there as well previously. His expertise was not accepted at the Pathology Society, but he had to present it in the Physiology Society. And then later, about 2 weeks or 3 weeks later, he published this landmark trial in the journal, and then it was widespread throughout the world, and it completely changed not only about this paradigm of tuberculosis. It completely changed how we looked at bacteria. And after that, he went on to discover the cholera bacteria and many bacteria after that. Not only his students were able to describe, to identify. But in 1882, there was another important development, thanks to this gentleman, Carlo Forlanini. He's an Italian. And he's the gentleman who discovered that collapsing the lung can improve the cure rate of tuberculous bacilli. We know that tuberculous bacilli needs oxygen. So in certain lungs where we can't treat them, if we deprive these bacteria oxygen, there are some successful stories of good outcomes. So he's the first one who developed creating artificial pneumothorax. So he combined oxygen and nitrogen and instilled into the thoracic cavity, creating an artificial pneumothorax. This is one of the pictures that has been earlier taken in the 1800s. And then because of that, there was a good outcome of most of these patients. And later, we know that this phenomena was expanded into thoracoplasty, where you artificially remove ribs and collapse the lung. And then patients, I know that some of you are, looking in a rather, in a little bit astonished way. Yeah, these are, because TB didn't have any cure. 70% of the people who had smear positive tuberculosis died within 2 years. So we didn't have any cure. So we had to have measures other than the conventional methods to treat this patient. And this is what will happen if we have extensively drug-resistant tuberculosis or completely drug-resistant tuberculosis in another few years if we don't control tuberculosis, right? So all of us will have to have thoracoplastic or plombages, and probably 50% of us will die anyway, right? So this is thoracoplasty, removing ribs, collapsing the lung. And this is actually putting plastic balls inside the lung to create, it's called plombage. And we put artificial, plastic balls inside the lung so that we can collapse the lung. And then by that, depriving the bacteria oxygen and the nutrition that are there. So these methods were there, and the development was there. Okay, so this is another important thing. This is actually the downfall of Koch. Koch was rather, he was like a godlike father, feature in the European as well as in the American continent because of his, deservingly marked studies. But unfortunately, in 1890, rather than being very vigilant, he published that I have found a cure to tuberculosis. And the cure he was describing was purified derivatives of the Mycobacteria tuberculous bacteria. So what he was telling was that by instilling or inserting this substance into a patient, you can cure tuberculosis or you can prevent tuberculosis. Right? But he was rather, for the publication about AFB bacteria, he had done tremendous amount of studies and he was very critical about himself. But unfortunately, before publishing this, he was not that critical. And later, they found that the tuberculin is not basically a cure. It cannot contain tuberculosis. And his reputation dwindled down because Koch is from Germany. there was a huge amount of people coming into Germany to take this cure, believing his word. And only the success rate which was described was about 1.7%. So he had claimed that he can cure, but he couldn't cure. And because of that, the and this is the famous study that showed that tuberculin is not a cure for tuberculosis. But later, it was developed into a diagnostic test for latent tuberculosis and sometimes even other types of tuberculosis as a surrogate for diagnosing tuberculosis. This says how much you will be, believe like a godlike figure in the world. Unless you are careful, the downfall is not far away. And the other reason that Koch had a downfall was that he refuted that the animal milk can give the disease to another person. And because of that, he didn't allow the pasteurization process, or he didn't recommend the pasteurization process. But unfortunately, or fortunately for the humankind, in 1900s, the US scientist has proven that pasteurization is beneficial. So because he was not for that, he was again getting less popular. One reason that he said this because he didn't like Pasteur. Louis Pasteur was a Frenchman. He was a German, right? And Louis Pasteur was a chemist. He's a clinician. So there was a certain, antagonism between them. And this again is a very good, thing to know about. Professional antagonism might cause your own downfall if you're not very careful. And this gentleman didn't do that. This is Clementin Jorin. He developed the BCG vaccination, right? So he actually inoculated the TB bacteria 250 times again and again and again and again. And then he found a non-virulent bacterial version of the tuberculosis bacteria and the Bacillus cementigeri. And actually, it was given first orally. I had a beautiful picture of it being given orally, but I don't have it now. It was first given to one of his associates' son, 2-month-old son. So the amount of bacilli that was given orally was 2.54 into 10 to the power 9, right? You can imagine. Now, usually the BCG vaccine contains about 10 to the power 6, a million bacteria. But there they have given a large amount of bacteria. But it has proven to be of benefit, especially in preventing the patients with neonates with tuberculosis. But again, there was a controversy because again, Germany was not for this BCG vaccination. And there was a part of Germany, the Lübeck, there they gave the BCG vaccine with the government's approval. But unfortunately, the vaccine strain that they used was contaminated with a virulent mycobacterium tuberculosis. And of the children, around 215 who were given, about 100, 110 died with active tuberculosis. So that's a Lübeck, this thing. And until about 1947, BCG was discovered in 1922, but until 1947, Germany didn't allow the BCG vaccine to be given. So if you're, and the people who were spearheading the vaccine campaign in Germany were criminally made responsible for giving the vaccine, right? So history is very important, not to repeat itself. Another very important gentleman in the TB criteria. This is Wilhelm Röntgen. Again, the wife comes into the picture. This is the first X-ray taken of the wife's hand in the world. And then you can see the chest X-rays that were taken. Until today, chest X-ray remains a very, very important armamentum, one of the most important aspects of diagnosing tuberculosis. And thanks to him, we were able to do that. Treatment of tuberculosis, unfortunately, was a very, far-fetched thing. The only thing that we could give is sanatoriums, give fresh air, give a bit of good food, fresh air, and sunlight to these patients. Nothing else could be offered because most of these people, especially sputum-positive tuberculosis patients, died within about 2 years. And even after that, because of the permanent damage of these patients had to the lung, most of them didn't live a normal life after that. And that there was immense suffering. And these are some pictures depicting about the suffering that this patient had with tuberculosis. So, these tuberculosis patients, especially the people who had money, could actually live in sanatoriums, expensive sanatoriums. But the people who didn't have money was just left for their own devices. And this is one of the pictures by Roye. He has drawn his wife dying without any support. And that is what is said, that there are many people who have died, famous people who have died with tuberculosis. Princesses, Chopin has died. Keats, the famous poet, had died. Certain residents of the United Kingdom has died as well. Princes have died, but unfortunately, majority of them don't have money, and they have died in billions. So for each person who we know who have died with tuberculosis, there was about at least 10 million people who have died without knowing because of the suffering that they had. That is the problem with tuberculosis. So tuberculosis basically is a disease that has evolved with us, as I told you previously. Multiple organisms type, even the tuberculosis complex have 5 bacterial species. And even that, after that, they evolve into clades. There are genetic changes that are there that has clinical implications of these patients. And there, because of that, there will be a virulence. They can withstand our immune system. One of the major factors that help them to withstand our immune system is their cell wall. These cell wall have properties which allows these bacteria to stay in our bodies dormantly, and at the same time stay in the microphage dormantly in the acid environment without getting destroyed. And that is one of the most important things. One of the main reasons is that these bacteria, when they are phagocytes, they undergo changes inside the macrophage, and then they get dormant. And when the appropriate things happen, appropriate environment comes, they become more active. And certain genes have been associated with this. There will be changes in the transcription of the substances that are there in the bacteria, where they will be upregulating or downregulated. And depending on that, the bacteria can survive a long time in our bodies. Right? And tuberculosis has many, many, many clinical presentations, which we have described previously. If either you destroy the bacteria completely, or it can remain in your body, or it can completely cause a disease at the onset if you have immune suppression. And other than that, there are many ways that tuberculosis bacilli can present to you, where now it is assumed that 50% of the patients are subclinical. That means the tuberculosis bacilli can stay in our body without being detected or without having any symptoms. So when this happens, when we don't have symptoms, diagnosis is delayed. An unfortunate thing is that 50% of the patients who have subclinical tuberculosis can give the disease to another person as well. So previously, we thought about screening with tuberculosis, especially pulmonary tuberculosis, with cough, shortness of breath, loss of appetite, weight loss. But now we know subclinical tuberculosis, none of these patients will have none of these symptoms. Only some radiological abnormalities might be there. And these patients, if we check for the sputum, it might be positive for gene expert or AFP. So these patients, people can give the disease to another person as well. So tuberculosis, hence, is a very, very, vast disease with many, many phases. Right? So these are the simple phases of tuberculosis in the lung, which we are describing. The pleura, you can have pleural effusions with nodules, and you can have vast clinical presentations of tuberculosis, which our colleagues will be discussing in the next few lectures. Various organs can be affected with tuberculosis. And even in the main person, even a single person, tuberculosis bacilli completely behaves in completely different ways. And that is why we need multiple bacteriocides, multiple antibiotics to treat against tuberculosis. And unfortunately, none of us don't know how to cure tuberculosis completely. Even though we define tuberculosis cured by giving 6 months of anti-tuberculosis treatment, and after that, if you are not having tuberculosis bacilli, we define them as cured, but we really don't know whether you are really cured, because some of these bacteria can stay in your body and give active disease in a later date. So it's a very, very challenging disease. unless you find a vaccine for tuberculosis, it will be difficult to tackle. And fortunately, there are two types of vaccines that are coming into the picture. So we know we talk about BCG vaccine, where we call it there is an area of difference where there have been mutations that are occurring, especially two virulent factors which are there in the tuberculous bacteria, which are called ESAT6 and CPF, ESAT10 and CPF6. Now, in this BCG vaccine, these are not there. So they have now developed vaccines, wholesale vaccines, which have mutated these genes. Hence, they have been to prevent be of much benefit. And they have been proven at phase three trials that the patient has been, there have been very, very positive inputs in these vaccines. So one thing is the MTB vac, and there is another vaccine that is coming into the picture. So briefly about the Sri Lankan picture, we had a very large amount of tuberculosis in Sri Lanka. In 1956, we had about 1,200 per 100,000 in Sri Lanka. But because of the good quality treatment that we had and the extensive healthcare system, we were able to actually bring it down to about 62 per 200,000, 62 per 100,000 by 2000. But still, by about 2020, we still see that the diagnosing of tuberculosis is 36 per 100,000, but we estimate that we have about 63 per 100,000. So there is a large amount of people who are missing in diagnosis. So that is the important thing. And the other important aspects of tuberculosis is that we have a large amount of tuberculosis deaths. So last year only, we had about 750 tuberculosis deaths. So with a disease that can be completely cured with effective drugs, especially in the context that we don't have multi-drug resistant tuberculosis, as well as HIV-associated tuberculosis, every day, 2 people dying with tuberculosis is a significant problem. And this is the people who are from the diagnostic cohort that the patients are dying. And when we analyze these people, most of them are having late presentations, have multiple cavitatory diseases and multiple comorbidities, especially diabetes. So prevention of deaths is a very important aspect in Sri Lanka as well. So currently we have two main problems in Sri Lanka: not diagnosing the patients who are there in the community. There is a delayed diagnosis. And I think it is time that we change the approach of diagnosis. Cough for 2 weeks might not be the best thing. So probably, especially in close contacts, we might have to go forwards and identify these patients, radiological changes and microbiological changes to diagnose a subclinical group of tuberculosis in Sri Lanka. Rather than just doing screening, we have to go for targeted screening in these patients so that we will be able to diagnose these patients properly and in an appropriate way. So the third thing is identifying and treating these patients as early as possible. So what are the targets of tuberculosis in Sri Lanka or in the world? Basically, we can see the two targets. Now, the main target of NTB 2025 is by reducing the number of TB deaths compared to 2015 by 95%, and reduction of the TB incidence rate to 90% from the 2015 rate, and TB affected families facing catastrophic cost due to tuberculosis, getting it to zero. So what about in Sri Lanka? What are the targets? Basically, the current TB incidence in Sri Lanka by 2015 was 65 by 100,000, 62 to 65 by 100,000. So by 2035, we are planning to bring it down to 6.5 by 100,000. And then we had about 648 deaths in 2015, but unfortunately, the death rate has increased in last year, and it has increased up to 747. We want to bring these deaths to about 32 deaths per year. And then catastrophic cost due to tuberculosis. We know that tuberculosis is a social and a psychological issue, and it's an economic issue. And majority of the patients have poor means of defending themselves, especially financially. And that is one of the reasons that we struggle. So at least these patients should be supported in a way that they will be able to take treatment without any problem. So tuberculosis per se is not a simple disease. It has, in a bacteriological way, it has many, many phases. And when you are trying to treat these patients, diagnosing will be a challenge. And I think Mudita will highlight the importance of that. Diagnosis is a problem. Management will be an issue, not a short duration, it is a long duration. And at the same time, it will be complicated by many social issues as well as economic issues to our patients. Hence, it is a very, very complicated disease which needs further action if we are to achieve the NTB targets by 2035. Thank you very much for your kind listening.